Morning guys, today we are back with another problem statement, and today's problem statement is minimum cost path. Okay, so this problem is a very famous problem of the DP series. This problem is a very famous problem of the DP series. So if you guys have not seen this problem, go make sure to like, share and subscribe to this particular channel, and you will get more amazing contents. So before any delays, let us just try to understand what this particular problem is saying. It is saying that we have been given a grid of size n, each cell of which contains an integer cost that represents a cost to traverse to that cell. We need to find a path from the top left to the bottom right cell by which the total cost incurred is minimum. By which the total cost income is minimum. Okay, so I will explain this problem statement with the help of a simple example first. Okay, then I'll come to the main example, then I'll tell you what are the techniques we can use, and it is going to be an interesting few minutes of time. Okay, so first is 5, 9 and 6. We are taking this example 5, 9, 6, 11, 5 and 2. Okay, so our task is, say for example, if this is our rows and columns are like this, so the 0, 1 and 2, 0, 1. So what our task is, we have to reach from 0, 0 to 0, 2. Okay, and we have to find the minimum cost or the minimum path sum. If somebody tells you, what we have to do is, you have to do the minimum cost slash minimum path sum. Okay, minimum path sum. So either of the two cases you can do. Okay, so let us take a path. Say for example, let us take this path. Okay, so if I take this path, what I'll be getting is 5 plus 11 plus 5 plus 2. Okay, 5 plus 11 plus 5 plus 2. So if I take this path, I'll be getting a 15, 16, 5, which becomes 23. Okay, which becomes 23. So what if I take another path? What if I take this path, which is 5, 9, 5, 2. Okay, 5, 9, 5, 2. So if I take this particular path, which is 5 plus 9 plus 5 plus 2, what I will be getting is a 21. Similarly, you can take this path. It is a 9 plus 5, which is around, we'll get this path, which is 14 plus 6, we'll get 21, 22. Obviously, if you take this path, it is still larger than 21. So 21 will be our minimum and the most optimal path. Minimum, most optimal path. Okay, but the condition is you can move in this direction or this direction. Okay, so the condition is you can move, you can say like this, you can move in the left and you can move in the up. Okay, and while you have to take the minimum of these two values. Okay, so I will explain you with the help of a code. Okay, and let us try to understand this problem. Okay, we will be given a 5, 9, 5, 9, 5, 9. What is this? 11, 5 and 2. Okay, so what is my approach and how I'm going to solve this? So say for example, I have a 5, and then I have 5, 9, 6, and then I have 11, 5, 2. So I'll be having a table, say distance table. Okay, distance table of two-dimensional matrices. So in this table, what my first task is to put the initial element, which is 5. Okay, so if I put the initial element, which is 5, I can say, yeah, I've got 5. Okay, what next? Now my task is to add the elements and make the sum of the rows at the first row and the first column. The first row. Okay, so 5 plus 9, I'll get a 14. Okay, 14 plus 6, I'll get a 20, like that. Okay, similarly for 5 and 11, I can take the sum as like this, that 5 plus 11, whoa, this is coming as 16. So I can say 5 and 1, which is 16. Now I have to choose this 5, right? So this 5, whether to be added over here or to be here, I have to take the minimum of these two values. So the minimum of 14 and 16 is 14. So if I take 14 and 5, I'll be getting a 19. Okay, in this case. Now I have 19. Now I have also 6. So that means 19 is there. I have 20 is there. Which is the minimum value out of 19 and 20? Is 19, right? So I have to add this 2 because I'll be moving from the minimum value to this. So I'll be getting a 21. So you can see in this way I can get minimum path sum equals to 21. So how we are going to solve this problem? We are going to write the algorithm for this particular problem and how we are going to solve this particular problem. So I can write the algo over here. Okay, so how we are going to solve this? Obviously, we are going to solve this with the help of recursion. Okay, later on I will come to the DP part, but first our task is, whenever the question says find all possible paths, then we have to use recursion. Okay, so the first is express in terms of I and j. Okay, that is our first task. Our second task is explore explore all paths, okay, and our third task will be take the minimum path, okay, take the minimum path. So I can write my recursive function as function like this, n minus 1 to n minus 1, which is my size. What this function does is it moves from 0 comma 0, as I already told, to it will move to n minus 1, m minus 1. Okay, so this is the initial task. So how this function is going to look? So I can say ing, I can say this function as ing. Initially, my first condition always is like I have to check the base cases, whether the rows or the columns is equals to 0. So I can write if I is equals to 0 and my j is equals to 0, then what I can do is I can return the array of, or the grid, in my case the grid of this. I have to take another base case. If the I is lesser than 0 or the j is lesser than 0, then return int underscore max. What int underscore max does is it basically returns it stores a very high value of integer. Okay, it returns a very high value of integer in order to avoid overflows. Okay, now my up value, since we are going to move up, what I can say, array of I and j plus, I have to call that function f of I minus 1 and j. So what f of I minus 1 it does, say for example, this is my matrix, okay, and these values are my j values and these values are my I values. So whenever I have to move above, whenever I have to move from bottom to top, I will be doing I minus 1. That's the reason I have told this thing as I minus 1. Now down, now left. For left, what is the function I will be writing? I'll be having an I and j initially. I'm having an I and j plus the function of, what I'll be doing is I comma j minus 1. So what I comma j minus 1 does is, if you're standing at this particular value, the value to your left is j minus 1. Obviously, this is the particular column and the previous column is j minus 1. That's the reason I have used up and left like that. And while returning, what we are going to return? We are going to return the minimum of the up value and the left value. That's all. But as you know that recursion will cause overlapping of subsequent subproblems, right? So we can say recursion causes overlapping of subproblems. So this is not an optimal solution to this particular problem. What we are going to do is we are going to apply the DP concept over here. So while we have to do nothing, as I already told you, recursion is the foundation of the DP course. So what we are going to do is we're just going to add the DP inside this particular snippet. So over here where I've written int max, I'll be adding one more line. If the DP of I and j is not equals to minus 1, I can return the DP of I and j. Okay, and over here wherever I have used up array, over here it will be DP, and over here also it will be DP. Okay, and while returning also we are going to return the DP of I and j equals to this particular value. But there is also a twist to this particular code. This code, when you execute this code does not pass all the test cases, especially when the input values of the matrices are as big as, say, 3 cross 3 numbers. What you can take, a 999 cross 999 table. So that's quite a big. So how we can solve this problem? And we will be using the concept of a priority queue. Okay, priority queue. And yeah, so we can solve this with the concept of priority queue. But before I move on to that, I want to show you that whatever you have learned is not wrong. Whatever you have learned is not wrong. The approach is correct. But before that, let us just execute this particular approach. So as you can see, what I have done is I've initialized the DP array over here. Then I've initialized the first array, the first row, and then the first column similarly. For the first row and the first column similarly. Okay. And then we are filling the array by taking the minimum of what I have done is the minimum of, for I minus 1 means the up value, and the minimum of j minus 1, which is the down value, and at the last we are going to add the present value I and j. Okay, and then we have returned the last element. As you know, any element, the last element is always the n minus 1 element. That's the way we have returned the n minus 1 element. Okay, initially we have to create the DP array, we have to initialize first row and then with the first column, and then we have to fill the rest of the DP array. So let us just compile this particular set of code and see our solution. You can see clearly that the expected output is matching in this particular case. Now if I try to submit this particular solution, what is the error? See, it is passing all the test cases. I should be saying you guys goodbye. But see, when the input value is 127. Here 127 signifies the number of rows and columns. That means it's a 127 cross 127 cross matrix, which is pretty big. And each of this matrix is very, very large values. So if you download this file, it will show you what are the large values, and the code output is not matching. Okay, so there is a significant change in the code output as well. So how we can optimize this particular solution using the concept of priority queue? I'll be solving this particular code so that you guys can have a clear idea of how you can understand this. But before that, before coding the priority queue, I would like to explain how the priority queue works. Okay, how every single thing works in this particular problem statement. Okay, so this is a long problem statement. As you can see, it's a hard-based problem statement, but still I don't want you guys to get bored or something. So I'll be explaining you nicely this entire code. So what you have is a 9499. Okay, this is given in our question. If you see in our question, if the question is 9499, then 6764 and so on. So first task is to, before coding, I will be writing the matrix 6764, okay, and 7 4 9 10. Okay, so in my empty table, I'll be filling all the values. What I'll be doing, I'll be filling all the values. So I'll be having a 4 cross 4, as this is a 4 cross 4. So I'll be having a 4 cross 4 table, which is my distance sum path table. I can call this table as distance path table. So what I'll be doing is I'll be presenting this, yeah, so it will become more easier. Initially, I will put this 9 over here, okay, and I'll keep doing the sum. So when I'm doing the sum, 9 plus 14, I'm getting a 13. 13 plus 9, I'm getting a 22. 22 plus 9, I'm getting a 31. Similarly, I will be putting the values. So 9 plus 6, I'll be getting a 15. Then I'll be adding the 7 to it. So I'll be getting 23. And 15 plus, I'm getting a 23. And after that, there will be one more column. 7, I missed. Don't get confused, guys. So there is one more column over here. 9, 6. Then the column will be 8, 3, 3, 7. And then the column is 7, 4, 9, 10. So what you can see clearly, that 23 is there. 6 plus 15 plus 8 is 23, and 23 plus 7 is 13. Okay, now let's come to the interesting part. When you have a 15 and 13, how we are going to fill the rest of the table? As I have already discussed, we have to take the minimum value. So the minimum value is 13, and the value present at this cell over here in the original cell is 7. So with this, we can say 13 plus 7 as 20. Now come to this particular cell. Okay, the minimum value is 20. The 20 plus this value at the cell is 23. So the answer will be 23. Now we can see that we are at this 23 and 30. The minimum value is 23. So 23 plus we can say 23 plus there's a 23. Okay, and the cell value which we are going to put is 4. We are not going to take 30 because 30 is greater than 23. So 23 plus 4, I can easily write over here as 27. Okay. Now let us come to this part. We have 20 and 22 at the same time. What we are going to do with 20 and 22 at the same time is the lowest value, which is 20. When 20 is the lowest value, what I'll be clearly doing is I'll be adding the value present at this particular cell, which is 6. I'll be making it as 26. Similarly, for 23 is the lowest, so 23 plus 3, this will become 26. And then we have a 9. So what I can say is 26 plus 9. We have a 26 plus 9. We can say this is as 35. Now let's come to this example. We have a 31 and 26, and this is 4. So 26 plus 4, this value will become 30. Okay. And then what we have is over here is a 4. What we have 30 and 26. So in case of 30 and 26, 26 is the minimum value. 26 plus 7. One minute, guys. So we have a 26. Okay. We have a minimum value as 26. So when we have a minimum value of 26, what we can see, the minimum of 26 plus 7, what I can write it like this, 26 plus 7, I can easily write it like this, so 7, 3, so it becomes, okay, it becomes like this. Now, I guess I made some mistake, 4, 26, yeah, it's 33 only. Okay, sometimes you get confused with simple calculations as well. So now we have 33 and 35 left, and our task is to take the minimum value and add the 10 to it. So if I add 33 plus 10, what my answer will become? My answer will become 43. Okay, so 43 is the minimum path sum. Okay, now you can match this. You can match this with the output as well. The output is saying the minimum path sum is 43. The route it is taking is 947337. Okay, the route, the following route it is taking is, the route it is taking is 947, okay, 337, okay, and this. But how we are going to take this route? We don't know how to take this route, right? That's the reason we will be using this DPA concept of taking the minimum values, then adding the sum to the adjacent values. The way I have solved this, I hope you guys could understand and relate to it. Okay, I hope you guys could understand and relate to it. Now I'll be solving this with the help of a priority queue. Priority queue. Okay. What I can say is initially I'll be having a table. Initially I can say this table as 9 4 9 9. Okay, 6 7 6 4. Okay. Now we have an 8 3 3 7, and then we have 7 4 9 10. When we have this particular table, how we are going to implement the logic? So what we are going to do is, we are going to initially make this table and make all the values as infinite values. So we'll be taking the starting point as 9, and rest all values I have said that we'll be storing very large values. So we will be storing with infinity in all the values. I can say we have stored successfully infinity in all the values. Okay. Now when I have stored the infinity in all the values, I can say that I have to make a priority queue, right? I can say that I can make a priority queue. Just a minute, guys. Yeah. So in this case, we can see that we have to make a priority queue. So in case of a priority queue, the priority queue will be having 3 elements: the cost, the row, and the column. Okay, the cost, the row, and the column. In the case of a priority queue, so the priority queue is a very long queue which will have multiple values. So let us make the queue look like this. Okay, let us make the queue look like this. So initially, I'll be also having a distance array. So I can say this is my distance array with 4 values, right? So I have to take 4 rows, 4 columns. So I'm taking everything big so that you guys can understand it. Also, smaller one will also do. Or smaller one will also work. Okay. So initially, what I can see is I have to put 9 plus 4 and 9 plus 6 in the queue. Okay. So initially, the value 9 will be there. Now I have to put the infinite values towards the right. Okay. So what I can write is, okay, 9 plus 4. We can say 9 plus 4 equals to 13, and 9 plus 6 equals to 15. 9 plus 4 equals to 13 and 15. So I can write 13 and 15 over here, and then I have to put the value of the priority queue inside the table. So what I will be putting in the priority queue, is 15 1 0 13 0 1. Okay. Once I've done putting the values in the priority queue, what next I am going to do? Next, I'm going to pop this element. Whenever I'm popping, I'm marking it. This is the first element I'm popping out of the priority queue. So when I've popped the element, what I'm going to do is, okay, so I have to do the calculation with the 13 1. Why I am popping 13? Because obviously I have explained 13 is smaller. So in this case, what I'll be doing is, I'll be doing 13 plus 7 in this direction. So 13 plus 7 will give me 20, and 13 plus 9 will give me a 22. So it is very clear. It is very clear when I'm getting a 13, over here, what I can easily do is, I can write it like this, that this is 22 and this is 20. Okay. Now, once this 13 is done, my next task is I'm left with this 15. That was the other one. So my next task is, I am done with this, but I have to add the elements of the priority queue as well, right? So I can add the elements 20, 1 and 1, and also I have to add the elements 22, 0 and 2. Why 0 and 2? These are rows and columns of this particular. Whenever I'm putting something, the first is the value and then the row and the column in the priority queue index. Okay. So you can see that I've taken 20 and 22 as well. Okay. So now next is I'll be popping 15. So 15 will be popped. So I can mark this in the queue. This is my queue, PQ, I can say priority queue. So I've marked this as 2. I've popped this element as 2. So when I've popped this element, what I have left is 15. I've popped 15. So I can move 15. In the below direction. Yeah, I can move only in the below direction as this direction is already been satisfied. So I can write like this. I can simply write like this: 15 plus 8 equals to 23. So in my distance array, I'll be putting, I can write this as distance array. I'll be putting 23. So once I'm done with putting 23 in this particular code, what I'll be doing is, I will have to check the minimum of this. Which is the minimum? Obviously 20 is the minimum. So I'll be popping off 20, 1 and 1. That's why this is coming under priority 3. So after that, I'll be adding the element 20 plus the element to the right and to the, or 20 plus element to the right and the element to the bottom. So what is the element to the bottom of 20? What is the element to the bottom? It is 3 and right is 6. So it is 23 and 26. So this is 23, 26. Okay, this is 26 and this is 23. So I can write 20 plus 3 is 23, 20 plus 6 equals to 26. Okay, I have come till this pass. I've come till this way. Now I have to again put the elements back into the priority queue. Recently I got 23 and 26. So I'll be writing like this 23. Okay, the 23 is located at 23 is 2 and 0, and I can recently put 26. 26 is located at what position? So if I take the position, this is if I take the position 0, if I take the position, if I clearly take this position 0, 1, 2, so 1 comma 2, so I can write 26, 1 and 2. Okay, 26, 1 and 2. So in this case, carefully you guys can see that I have successfully put these values. Okay, so I have popped this value as well. What are the values still remain? I have a 22, 0 and 2. Now next value is 22, 0 and 2, which is left to be popped. Okay, so when I'm popping 22, 0 and 2, which is this value, what I can clearly see is I have to go either this direction and this direction. So when I'm going, I have only one direction. Okay, when I'm going, I have only one direction. So the only direction which I have is 22 and the value is 9. Okay, so I can write it like this, that 22 plus 9 will give me a 31. 22 plus 9 will give me a 31. So I will done with this as well. So now what I'm left, recently I've added 31. So the 31 is located at which position? 31 is located as 31, 0 and 3 position. Okay, 0 and 3 position. So now what is my next element? The next element is 23, 2 and 0. 23, 2 and 0. 23, 2 and 0 is the next value. So what is 0, 1, 2 and 23? 23, 2 and 0. So this value, I am standing at this value. I have to go below or I have to go right. So when I have to go below, what I can see is 23 plus 7, which is 30. So I can write clearly 23 plus 7 equals to 30. I'll be putting 30 over here in the distance array, and I have striked off this value. So the fifth element is also gone. So I can write 30 is present at 3, 0. Okay, third row, 0th column. That is also done. Now what we are done? Now we are left with 26, 1 and 2. Now we are left with 26, 1 and 2. So 26, 1 and 2 is which one? 26, 1 and 2. 26 is there 0, 1, 2, 1, 2. This one. So I can go in this direction. I can go in this direction as well. So when I'm going in this direction, what I'll be doing simply is I will be doing 26 plus 4. I'll be doing 26 plus 4. So this becomes 30 and 26 plus so this becomes 30. So I can write 26 plus 4. I can write this like this, that 26 plus 4. So 26 plus 4 equals to 30. So when I'm putting 26 plus 4 equals to 30, so I can write it like this. This 30 is 3 comma 3. This 30 is 0, 1 and 3. So first row, third column. So this looks like a clumsy, but it's okay. This looks a bit clumsy, but it's okay. Now once 30 is done, once this value is done, so what recently I did is I have completed 26, 1 and 2. Now I'm left with 31, 0 and 3. Now I'm left with 31, 0 and 3. So where is my 31? 31, 0, 3. So when 31, 0, 3 is also completed, so I will strike this off. Now I'm left with 30. I'm left with this value 30, 0, 3, 0. Okay, 30, 3, 0 means third row. Okay, column 0. This value. When this value is there, I have to carefully check whether I can do this calculation or not. Okay, so what I can do is I can do 30 plus 4. Okay, I can do a 30 plus 4 to make it 34, or I have 23, which is my minimum value, 23. So I cannot do 34 over here. Okay, but technically I should be doing 34. So what I'll be taking is the minimum value, which is 23. So with 23 and 4, I can get a 27. Okay, I can get a 27. So I will write 23 plus so I can obviously strike this. I can obviously strike this value as well. I can obviously strike this value of 33, as well. Okay, and I'm putting a 27. So I can write it like this. I can write it like this, that since I'm doing 23, so 27, the row is 3 and the column is 1. Okay, the row is 3 and the column is 1. After that, what I can see is having our 23. What are the other values I have? I have this value. I have this value with me as well, which is 30. Okay, which is 30, 1 and 3. Okay, so I'm in this value. What I can do is I can go in the direction below. I can go in the direction below. What I have is a 7. Okay, what I have is a 7. What I have is a 7. So either this value can be a 37. Okay, or what I can do is I have 23 as well. 23 and 26. As you can see, then if I do this thing, this is not going to work. So I'll be doing first, I will be doing is I'll be taking the minimum of 26 and 23. I'm having a 23, and with 23 I will be adding a 26. See, this becomes 26. Now I have 30 and 26. Now which is the minimum again? I have the minimum as 26. So I will be doing 26 plus 7, which will be getting a 37. No, which I will be getting a 33. I'll be getting a 33. Similarly, I have to do the rest. I have to pop the elements, and then there will be a time that I'll be getting this value as 35 and this value as 43, and my 43 will lie in this position 43 3 comma 3 in the stack. And when you pop this, you will get the distance. When you pop this, you will get this particular distance of 43 as the correct answer. This particular distance of 43 as the correct answer. Now it's time to analyze the solution. Now it's time to analyze the particular coding and implementation of this particular solution. So I can see that I have a minimum, that you can see that I have a minimum cost path sum. You can see clearly that I have a minimum cost path over here, okay, minimum cost path. So my first task will be, my first task of the day is to just a minute. I can take the directions, right? I have to take the directions. So I can say private static int final int. So private static, sorry, this value as final int. You can say direction of the row. I can say this direction of the row is equals to, I can put the values -1, okay, 1 0 0. This is the direction I am moving. Similarly, I will be taking the value for the columns, so I can write it like this: direction of the columns BC, and the direction of the column will be just the opposite. So in the direction of column, I can write 0 0 -1 and 1. Okay, now we have a minimum cost path. Now we have a function minimum cost path, and how we are going to work with this function. So initially, I'll be taking the value of the length. So I can say n equals to grid dot length, grid dot length. So I've taken the length of the grid. Okay, now we have to initialize all the distances as infinite, as I already told you, except the starting distance. Okay, so I can write for loop int row present in the distance, which is the int row present in the distance. So I can obviously take a distance array. So int new distance array equals to new int, making a 2D distance array. So if my row is present in this particular distance array, what I'll be doing is arrays dot fill with infinity. Arrays dot fill with infinity. So row comma integer dot max underscore value. Okay, I'm getting a integer dot max underscore value. So I've covered the row. Okay, now my starting distance, obviously I said it has to be the first point. So I can write distance of 0 and 0 equals to grid of 0 and 0. Okay, as I've done the distance, now what I'm left is to initialize the priority queue. Okay, initialize the priority queue. So for that I'll be using priority queue data structure, a priority queue data structure of the type integer array. I can name this as pq equals to new, just a little bit of fast word, new priority queue. In this okay, new priority queue. So in this I'll be passing a comma b, okay, then greater than, and this priority queue having a condition where a has to be greater than b. So I can write a of 0 minus b of 0, okay, b of 0 minus b of 0, and then a semicolon. Okay, so I hope I have done this. Now to add the elements in the pq which I have just made, so I can write like this: pq dot add, I'll be writing new int. Okay, so in the grid I'll be writing 0 0. Okay, I've written 0 comma 0 comma, I can write 0 comma 0. Okay, and then I have a curly bracket, then this thing gets closed, and a semicolon. Okay, once this is done, I can write while my priority queue dot is empty. Okay, is empty. So you can write int my current equals to, I can say current array to store the current value of the element. I have to remove, that's the reason I have to use pq dot whole. As I've already explained you the priority queue in detail, you guys must know right now. Now I can say int current cost equals to current of 0, okay, and I equals to, I can say, current of 1, and j equals to current of 2. Okay, so what is this basically doing? We have already said that PQ contains, first PQ contains the cost, then the row, and then the column. As I have explained over here, that PQ contains the cost, the row, and the column. That's why there are three elements in the priority queue taken in one particular line. Okay, so I have done J as current of 1 and 2. Now we have to check if we reach the bottom right corner, then we have to return the cost, right? So what I have to put an if condition, just simply put an if condition. If my I value is equals to, if my currently my if my current uh, so just, yeah, if my I value is equals to n minus 1, and my j value is also equals to n minus 1, that means I have reached the bottom right condition. That means I can say reached the bottom right place, okay, whatever it is. So I can return the current cost, okay, current cost value. Now we are left with the last and the final part, which is exploring the all four directions. Okay, checking all four directions, because whenever you are at a particular point, you can check the directions in while putting. I have shown you in some cases when there are multiple elements, you have to check the left, the right, the top, and the bottom value as well. We have to check all the four directions. Okay, we have to check all the four directions. For that, I'll be using a concept of int d equals to 0. Okay, d less than 4, d plus plus the directions, okay, d plus plus. So I can write int new row equals to I plus what was my distance of the value, dr. So I've taken it as dr. I will write it like dr, sorry, dr. In the dr, what I'll be doing, I'll be passing this value of this distance. Okay, so I've taken the drd. Similarly, int new column equals to j plus dc of d. Just the same thing. Okay, dc of d. Once this part is done, I have to check if new row is greater than equals to 0. This is the same base cases, and new row is lesser than end, and new column. What I have said, this is a new column. So new row I have done. Now I have taken new column as also lesser than 0. Okay, so I have taken new column as also lesser than 1 is new row greater than equals to 0, new row is greater than equals to 0, new row less than n is also done. Okay, and lastly new column is lesser than n, and one condition I'm missing, new column is also done. So I can write new column greater than equals to 0, and okay, so this part is done. New column is new row, both the new rows are lesser than n, both columns are greater, rows and columns are greater than 0. Okay, so if this condition is done, what I'll be doing is int new cost. I'm taking a value as new cost equals to, int new cost equals to, what is my current cost? So this is my current cost value plus the grid. I have the clearest value. Okay, so in the grid I will pass in the new row. Okay, I'll pass in the new row in the grid, new row and column, as a grid is made of row and column. So definitely it will be a bit hard for you guys to understand who are coding in Java for the first time, but slowly the more concepts of DP you guys will be practicing, this thing will become a piece of cake for you guys. Okay, so initially I have taken the new rows, the new columns. Okay, now I have to check, I have to give another condition. If my new cost is lesser than the distance array will have new row, new column. Okay, so I can write it like this: the distance of, to update it, every time I have to update new column equals to new cost, as this is our new cost. We have recently made new cost. Yes, we have made new cost. Okay, and in the priority queue dot add, I can say new int. Okay, new int in the priority queue cost, row and column. So I can write new cost, new row, new column. Okay, so I have made the priority queue as well. Okay, after that I'll be closing the small if, this if, the distance array if, eventually the while loop as well, okay. Finally I'll be returning the distance array of n minus 1, okay, and closing this function. Let us just try to check. Okay, so I have array dimensions missing in distance. Int distance, where is it? In line number 42. So I will be putting the distances as n and n. Let's compile. Cannot find symbol n, as so this has to be coming below this. Only then it can find the length. So we have successfully completed the problem. Let's submit it. So this was a very big problem. It's a hard-based problem, but it is one of the best problems in DP, minimum cost path. Even if you solved this using the previous approach, which was not using the approach of priority queue, then also you would have got partial test cases passed, and you could have at least cracked your interview if they have asked you in an interview question. But for more optimization, we will be using a priority queue. Okay, and make sure you guys like, share, and subscribe to the channel. Thank you so much.